Welcome to the Chapter 5 review outline talking about randomness and probability in simulation. So, sample space is just the list of all possible outcomes. So, if I'm rolling a die, the sample space would be 1, 2, 3, 4, 5, 6. Mutually exclusive or disjoint, they mean the same things. That is two events that cannot happen at the same time. You come up to a traffic light that is both green and yellow at the same time. It's not going to happen. Independent. Knowing the outcome of one event doesn't affect the probability of the second event. We would say that those events are independent. So a couple of formulas. We didn't use formulas too much during the unit, so I wouldn't really stress these, but totally up to you. The probability of A or B, or would be your union symbol, is the probability of A plus the probability of B minus the probability of A and B. If you have mutually exclusive or disjoint events, you can add the probabilities because there's no overlap. Multiplication rule we use when we're doing tree diagrams. We didn't really use this formula explicitly, we just applied it. If you have two events that are independent, then the probability of A and B happening is just the product of those two events. And then on the AP exam, if they ask you to prove if events are independent, you're going to check one of these two formulas. Given that B happened, it didn't affect the probability of A. So in our bag of tools for probability, we have a bunch of different strategies. A two-way table, that would be what I suggest that you use. Venn diagrams, you remember me saying I'm not too big of a fan of those. Tree diagrams, the formula, or simulation. So let's look at a simulation. If we're trying to predict the probability of getting a total sum of 4 when rolling 3 dice. So what I want to do is I want to roll the 3 dice 20 times. And if I just use a random number table and I'm just looking at the numbers 1 through 6, so I'm ignoring the rest, 3 at a time. And I'm trying to, and then basically I'm going to look, what is the sum of those 3? Is it 4 or is it not? And then calculate out of those 20 repetitions, like how many of them had a sum of 4. So, and then something like, hey, we estimate the probability to be 0 out of 20 based on our simulation. That's not the law of large numbers. We just did 20 trials, not a large number. So it's not going to be necessarily the most accurate, but that's how you'd run through a simulation. So getting to some more applications. Here, in a group of 120 students, 40 said they have seen Wagon Attack 2. I don't even know what this movie is, by the way. I was going to update it, but I just didn't. And 40 had seen that, 20 have seen this, and 10 had seen both. So here's your Venn diagram. One of the things you have to remember to do is subtract the overlap. So the Wagon Attack is just 30 plus the 10 overlap. That's where the 40 comes from. And the 10 plus 10 is the 20. So 30, 40, 50, there's 120 total. So that's where the 70 comes from. That's why I prefer the two-way table. You're more used to them seeing them in Algebra 2. So that's the two-way table. If a student is randomly selected, what is the probability they have seen one or the other? So you can use a formula here. There's a lot of different ways you can do this. Let me get a highlighter real quick. You can use the formula, or if you understand or means one or the other or both, just sum these up. Or let's see, Wagon Attack or easier said. So I'm looking at the sum of these, 30 plus 10 plus 10, not including the totals. You don't have to use the formula. Example 3. So she's a nervous basketball player. She's got a 40% chance of making her first shot. If she makes it, then her second shot, the likelihood is 70% that she makes it. But if she misses, then it doesn't change. It still stays at that 40%. So having read through this situation, you have to understand that this is a tree diagram because these are conditional probabilities. If she makes her first shot, if she misses her first shot. So the second tier of the tree diagram, these are conditional probabilities. This 0.7 is the probability she makes the second given she makes the first. So this whole column is conditional probabilities. Then I'm going to multiply across the branches. That's using the multiplication rule, but we're using it in the background. We're not really forcing the formula. And then this gives me the probability all the possible outcomes. I'm summing those up just to check the probabilities 1. So a couple follow-up questions here. What's the probability she makes her second shot? That could be a make and a make, or a miss and a make. So I'm really looking at the sum of these two. That's where the 52% comes from. And then part B is a conditional probability. If she makes her second shot, that's the given. What's the probability she missed the first? Well, we just said there's a 52% chance she makes the second shot. So what's the probability she missed her first? Out of those 52%, 24% of the time she misses the first. So that's how I'm going to apply that. And I believe that's it. All right, so that's a quick review of probability.